So we are looking at macro fiscal issues, and in this podcast we'll continue with further details like defining adaptation investment needs, which is what macro fiscal management will be all about, how to create space for adaptation funding. Investment needs in climate change adaptation can be defined as the difference between optimal investment levels with and without climate change. So this is typically what attribution of climate change tends to be all about. So let's say you detected a signal that temperature in a particular region or rainfall pattern, snow, something is changing, and you detect it over a certain time, and then you want to understand if that's due to climate change or if climate change made it worse. This is called attribution, so detection and attribution. And there are various techniques we have discussed elsewhere in other podcasts. So what do you need to attribute? You need a counterfactual world. So you need to understand what would have happened to the rain or temperature at this place if there was no climate change. So somehow you have to create this counterfactual world. Here we are talking about optimal investment levels with and without climate change. So for your region, you have found some information, let's say from IPCC or the National or Regional Climate Agency, which says things are going to change here, temperature will change, precipitation will change, which means there will be need to manage water resources, agriculture, crop selections, etc. So there is a counterfactual world where these changes don't happen, but you have information that these will change. So you have to compare the counterfactual world with what is expected to happen to make decisions on how to adjust the various factors to go forward. So quantification of adaptation needs requires defining optimality and developing economic models that can derive optimal investment levels under scenarios with and without climate change. So you can see already there are uncertainties in figuring out the counterfactual world where climate change didn't happen, because then you have to see what is forcing the climate change, greenhouse gases, land use, etc. And then you have to translate those physical risks to an economic model. So you have to be careful about the uncertainties that cascade through the system. This definition can be applied to identify planned or executed climate change adaptation spending. Okay, to read that, for specific projects in practice, a simplified application is to count the projects that are only implemented because of climate change, and for those who would be implemented anyway, to count the additional cost incurred to adapt them to climate change impacts. So there will be some actions that will happen anyways, and then you either modify the action that was going to happen anyway, or you initiate new actions to adapt to climate change. Could be infrastructure, sea level protection with seawalls, and natural defenses like increasing mangroves, and various examples can be imagined. This definition can be relevant to track climate change adaptation spending in national budgets and in international aid. So depending on which country it is, there is going to be a plan, a costing from the economic perspective for adaptation investment needs, and then you're going to see how much you can afford and how much international aid has to be sought. The adoption of strict additionality to define climate change adaptation needs excludes the cost of closing the gap to achieve an optimal level of adaptation to current climate conditions. So what is additionality? Basically, some things are changing, let's say because of natural causes like increased population, increased deforestation, conversion to agricultural land, or urbanization. These are human activities which do affect climate change, but let's say they are not directly related to greenhouse gas emissions, which are global as opposed to local land use change. Then additionality is basically what your natural economic growth activities are doing, and then what is added on top by climate change in terms of investment needs. So this sentence is complicated, so let's read it again. The adoption of strict additionality to define climate change adaptation needs excludes the cost of closing the gap to achieve an optimal level of adaptation to current climate conditions. Okay, so you have current climate conditions which are already happening, maybe in terms of heat waves, floods, droughts, many things, and there is going to be additionality of cost or adaptation required that will need estimation of cost. Okay, so you have to, there is additionality of climate change forcing adaptation needs, then there is additionality of cost as well. A broader definition of adaptation needs that includes adaptation to the current climate should still exclude investment needs that are primarily driven by other development needs. What does it mean? Adaptation costs can be hard to separate from other development needs when development and adaptation are self-reinforcing. So economies like India and China are growing, they are building a lot of infrastructure, and this is adaptation for their own needs, but then you have to worry about infrastructure risks in the future for coming from climate change. Then you may have to include these, which requires to your primary needs may be driven by growing population, growing transportation, growing number of cars, etc. But then climate change adds something on top. For example, education has sometimes been cited as an adaptation cost because climate change makes education investments even more needed, especially for the most vulnerable. And we know that vulnerability is reduced in places like India to climate hazards when women are educated, because then they are better at assimilating early warnings and taking action to protect their family and property, etc. A more educated population can learn faster about new technologies and can transition more easily to climate resilient practices and sectors as well. However, climate change will likely have negligible effect, if any, on education goals themselves. Therefore, the bulk of education needs should not generally be counted as adaptation needs. So you know how when there is money to be spent and money is set aside for certain purpose like infrastructure, then how do you add climate adaptation needs into that, and what do you call climate adaptation need? These become quite complicated. Alternative definitions that would classify investments that are primarily driven by development needs as adaptation needs would lead a very large and potentially misleading estimation of adaptation gaps. Such definitions may lead countries and international donors to double count some development needs. So adaptation gaps are essentially where you need to be in, let's say, in terms of investments to protect against climate risks that are coming down the pipeline, and you have development needs for which you are building things. So development funds that you receive may count development needs and then adaptation needs, and basically double count the aid that is being given, and this can essentially create macro fiscal issues again for definition for investment needs to adaptation, investment needs for adaptation. So it's kind of qualitative statements, and yet economic models have to worry about those things. So now you're mixing economic models with adaptation needs and development needs and trying to see which one is additional cost and which one is a cost that would be incurred anyways just as a primary development need. Okay, moving forward, estimation of adaptation needs. Global public adaptation needs are estimated at around 0.25% of the world GDP per year on average, but may not be representative of the challenge faced by many countries. So this GDP, world GDP percentage at quarter of a percentage point is not to help every country. It's not a pool of money taken from world GDP to help everybody, but it's an estimate of all countries facing climate challenges and their adaptation needs and the cost aggregated to the world level. Estimates in the literature indicate that global investment needs in climate change adaptation for developing countries range from insignificant amounts to 300 billion annually in 2030 and between 50 billion to 500 billion annually in 2050. So the numbers themselves tell you that there is large uncertainty, and what you will need in 2050 will of course depend on what you did by 2030 or 2040. So the upfront cost can be higher at, let's say, 300 billion annually in 2030. In 2050 it may be 50 billion, as low as 50 billion if proper actions were taken for the ramping up of climate change impacts by 2050, or it could still be going up to 500 billion annually by 2050. As a share of average annual global GDP, investment needs in 2030 range from almost nothing to about 0.3% of projected 2030 global GDP per year. We'll look at this in a figure. In 2050, the investment needs increase in all studies, even after accounting for global economic growth. So remember, there is the absolute amount needed, and then you're talking about percentage of GDP. If GDP keeps growing, then the amount associated with this percentage will grow as well. So the two numbers can be very different. These estimates are highly uncertain because they rely on just a few studies and they are not very recent. They are quite dated by now, especially by the time I'm recording this podcast from a report that's about a year old. The wide ranges can be explained by differences in the definition of needs and in assumptions about future development and climate change, which we looked at before. So we'll come to figure 2 in a minute, which is this: estimates of global investment needs in adaptation. So these are very different applications with different IAMs, or integrated assessment models. So UNEP offered two estimates, low and high. There are several authors which produced different model estimates from DICE, which is the Bill Nordhaus model, which is another integrated assessment model. World Bank has its own estimates over time, but you can see the years are more than a decade old as I'm recording this in 2023, so I have to be very careful. UNFCCC is self-provided low and high before just after the AR4 report was released, and then there are other studies which make different assumptions about the costs based on unmitigated low, unmitigated high. So whether mitigation has been reducing the impact of human activities on the warming or not. And then there are others which used the global warming targets such as 2 degrees C, but nonetheless you can see percentage of projected GDP per year is as high as above 0.3% by 2050, or as low as in some cases close to zero here by 2030, and as low as 0.04% here by 2050. So I won't go into all the details, but just see how large the uncertainties are, and whether these need to be done again to update these numbers with the new knowledge we have about where we are in terms of the actions we have already taken. Basically not much good news in the sense the emissions continue to go up, but good news in the sense of increasing renewable deployments, electric vehicles, battery technologies, energy storage, etc. Okay, so box 1 we'll come back and look at in the next podcast because it's a bit long. So let me stop this podcast here. It tells you about estimating investment needs and adaptation needs as well. Okay, so we'll come back and continue.